Assalamualaikum warahmatullahi wabarakatuh. Okay, can you hear me, ladies and gentlemen? Can you hear me? My voice clear? Test, test, test. Can you hear me? My voice
Yes,
okay,
yes,
clear? Okay,
yes.
okay, okay. Assalamualaikum warahmatullahi wabarakatuh. Good morning, or good afternoon, or good evening, ladies and gentlemen, depending on where you are. Uh, the distinguished speaker and all participants, welcome to the 7th International Conference on Climate Change 2021 in the parallel session in room 1. And I would like to extend my gratitude to all of participants for joining this session today. Alhamdulillah. First, let me introduce myself. My name is Pringgo Widyalaksono. I come from Universitas 11 Maret. I will be responsible for hosting this session today. So, second, I will tell about the guideline on the rules for the presentation session today. The presenter will be give around 8 until 10 minutes for presenting your presentation, and after that we have 2 until 4 minutes for discussion session. So maximum 12 minutes for presentation. So in this first session, I would like to welcome the first speaker today, Mrs. Septia Dwi Sahputri, who will present the title Carbon Dioxide Gas Emission from Several Types of Peatland Used in Kinali, West Pasaman Regency, Indonesia. Please, time for you, Miss Septia. Are you ready?
Okay, sir, I'm ready.
Okay, okay. Now your turn.
Okay. Okay, thank you, Syar. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Hello, everybody. Introduce myself. My name is Septia Dwi Sahputri, and my supervisor is Mrs. Professor Dr. Insinyur Yulna Fatmawita, MSc. We from in Faculty of Agriculture, Andalas University, Padang West, Sumatra, Indonesia. And we research title is Carbon Dioxide CO2 gas emission from several types of peatland used in Kinali, West Pasaman Regency. Next, sir. Okay, next, sir. PPT.
Okay. Host, maybe the host, Mr. Okay. Second slide, maybe.
Yes.
Okay.
Next. Oh. Next session, sir. Okay.
Wait a minute, maybe the admin have problem for the presentation slide. Is this slide from your computer or from the admin maybe?
No,
Oh, from admin.
dari ya, from operator.
Oh.
Can
Oh, you can.
yang share screen.
Okay, you can share screen. Okay, no problem.
Okay. Please close the share screen. Okay, sir.
Okay, please slide view maybe it's better.
Yes. Sorry, sir. Okay, introduction. Kinali is located next to the Indian Ocean in West Pasaman, West Sumatra Province, Indonesia. Peatland area is 15,000 hectares. It is passed by several rivers, Batang Masang, Batang Mandi Angin, Batang Kinali, and the other. Change of peatland use from forest into farming, land will change the management give, and finally will affect carbon dioxide emission. And this is peta in West
Sorry,
Pasaman.
your slide still in the first slide.
Yes.
Can you
Next,
not view that? Maybe admin, can you close the share screen first, because the slide of Miss Septia not appear yet.
Okay. This, sir.
I'm not sure. Only my screen or another screen also cannot see your second slide because
okay. Material and method. Peatland in Kinali has been changed into 5 main types of land use. Is oil palm plantation, mixed garden, bushland, seasonal cropland, open land. It is land use types. It was foundation. Is 1. File observation. Is peat depth, water table depth, soil color, degree of maturity, air temperature, and humidity, as well as carbon dioxide emission. Carbon dioxide emission was measured using in infrared dispersive sensor (NDIR). And the last laboratory analysis is soil moisture, soil water content, OC, and total nitrogen. And this is land use types in Kinali. There is oil palm plantation, mixed garden, bushland, seasonal cropland, and the open land. And the result, my research is this one: carbon dioxide emission from peatland in Kinali. This is based on GMP analysis. It was found that there was no significant difference of carbon dioxide emission from all types of land use. The highest amount tend to find under oil palm plantation, and the lowest was under mixed garden. This was highly affected by the SOM content of the peatland. And 2, air temperature and humidity. There was a significant difference of air temperature due to types of land use. The highest air temperature was under oil palm plantation, and the lowest was under open land. However, the temperature was above 30 derajat Celsius. However, the humidity was high enough between 83 and 87. It was not significantly different among the land use. And next, SOC content. SOC content. The SOC content of the land use was significantly different. The highest was under palm plantation and the lowest was under mixed garden. This was most affected by the water table. The depths, the water table, the more the pit material being oxide, so the low is the SOC content. Next, soil moisture content. Soil moisture content was significantly different among types of the land use. It followed the SOC content of the soil. And next, the total nitrogen content. Total nitrogen content of the soil was significantly different among the types of land use. It followed the SOC content. And the last, shaper and ratio correlation between OC and total nitrogen content of peatland. There was significantly R 0,787 linear correlation between SOC and total nitrogen. The shaper and ratio was the lowest under oil palm and the highest was under mixed garden. And this table 1 depth of water table, degree of maturity and color of the pit soil. And this is the degree of maturity, the all land use peatland in Kinali is sapris. And one Hemis is bushland in 3P until 6P. Okay, the conclusion, my research is based on the data analysis, it could be concluded that one, carbon dioxide emission from the all types of peatland being measured in Kinali was not different among the land use types. And two, the pit soil was classified as saprit for all types of land use. And the water table depth was small, 100 centimeter. And the last, the environmental conditional, especially temperature, soil moisture content, SOC, shaper and ratio was different, while the humidity was relative the same among the land use types. Okay, thank you. Thank you for your attention and Assalamualaikum warahmatullahi wabarakatuh. Okay, sir.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you for your presentation, Ms. Septia. I'm sorry, maybe this technical error of the slide. I'm not sure because your slide, we have problem with your slide is still in first slide, but with your explanation, I hope all the participants understand about your your presentation. Okay, let me start with this discussion. If any participant who will ask question or something, please, or you can tag me with the chat box. No, or maybe I will start for the first time. What do you think the most contribution from your research for the climate change issue, Ms. Septia, from your research?
Okay, I'm sorry, sir.
Okay. What is the most contribution from your research with the climate change issue? I think. What is the specific contribution from your research?
Kontribusi my
yes research. Your most contribution research in your research with the climate change issue.
Okay, my research is carbon dioxide. Yes, carbon dioxide. CO2 in the land use, peatland.
Okay. Oh, in the peatland.
Yeah.
Oh, I see.
And the pit lane is okay, I'm sorry, sir. Can I speak in Indonesian?
Oh, okay, no problem. Okay. 1 minute. Okay, 1 minute.
Oke. Untuk kontribusi dari penelitian saya sendiri itu yang berkontribusinya tuh menurut saya dari karbon dioksida sendiri. Karbon dioksida sendiri yaitu dia kan dari tanah gambut. Di situ tanah gambut itu memiliki banyak bahan organik. Banyak bahan organik di sana. Dari sanalah ketika bahan organik itu melakukan proses dekomposisi itulah yang terus-menerus di tanah gambut, sehingga dari proses dekomposisi inilah dia menghasilkan gas karbon dioksida
Oh,
tersebut.
oke, saya paham. Oke, saya jelaskan. Oke.
Yes.
Okay, thank you very much for your explanation in Bahasa. I think Miss
Yes, sir. I'm
Septia
sorry,
tried to explain about peatland
Indonesian.
contribution to decompose the CO2, carbon monoxide to be oxygen, something like that. Okay, I think that's all for the first session. We continue to the second session, the second presenter. I would like to invite Mr. Iwan Setiabudi from Universitas Pertamina, maybe. Are you already joined this session, Mr. Iwan Setiabudi? Mr. Iwan Setiabudi. Okay, now it joins. Okay, Miss Iwan Setiabudi. Mr. Iwan Setiabudi, or on behalf Mr. Iwan Setiabudi, maybe can present the presentation. Okay, not yet come.
Slide-nya berubah nggak, Pak?
Coba slide kedua. Nggak berubah itu, Mas. Kenapa ya?
Kelihatannya apa, Pak?
Ini kelihatannya slide presenter gitu. Presenter view. Nah, ini berubah kedua. Tapi
Kalau di slide so mungkin belum bisa ini, Pak. Kayak ini slide berapa, Pak?
ini slide kedua.
Ini udah ganti belum, Pak?
Masih slide kedua.
Berarti slide-nya nanti ini. Ini ya, Pak. Ini bisa gantikan, Pak?
Ini bisa ganti. Ini bisa ganti. Lancar ini. Oh, because Mr. Iwan not appear yet. Is it okay? I will ask to all participants. Is it okay if we continue to the next presenter? I know about the schedule, maybe not the right time.
Aman. Satu.
Is it okay to continue to the second presenter?
Yeah.
But I think the third presenter pun oh okay. Thank you, Miss Vedasa Benti, for your I would like to invite Mr. Mahawan Karuni Yasa, the third presenter. I think also not ready yet. Maybe he will come in the third session, third schedule. And then maybe is it okay? I will like the next presenter, Mr. Fekadu Aduguma. Are you ready for present? Not in your session, your time, because we try because there's two presenter before you not ready yet. Are you ready, Mr. Fekadu? Fekadu, can I call you Fekadu or Duguma? Mr. Duguma, maybe. Please unmute your mic. Okay. Please unmute. Okay. Okay, you can start, Mr. Fekadu. Your voice not yet here. I'm sorry, I can hear your voice still. Your slide okay, but your voice not appear yet. I can hear your voice.
Can you hear me now? Can you hear me now?
Okay. I can hear you clearly.
Okay.
Okay.
Ah.
Okay.
Sorry.
Okay.
Sorry. Okay. Thank you everyone to invite me to this important session. My title is Hydroclimate Trend Analysis of Upper Awash Basin, Ethiopia. As a background introduction, the hydroclimate of East Africa shows a distinctive variability on the seasonal and decadal time scale. And like El Nino, Indian Ocean emerged are influencing sometimes. So the country is facing flood and drought from poor water resource management with reluctant policy. We can say that by reviewing different literatures. But scholars believe that East Africa water town is Ethiopia. Contrarily, we are facing drought and poor flood. Hence, essential water resource development with the optimal utilization is vital for sustainable agriculture-related economic development. A country has basically 12 river basins. Almost about 10 of them are transboundary, while Awash River Basin is not transboundary, and Rift Lakes are also not transboundary. Nowadays, the Awash Basin is known for high climate variability involving drought and flood. Climate change will intensify the existing challenge also. Awash River Basin is where in a modern agriculture was introduced in early 1950s and the most irrigated basin, so that it is considered as an economical basin for the country. From land use dynamics and urban expansions, most of cities and towns are existing within this basin, including the capital Addis Ababa, Bishoftu, Adama city, the major cities So accordingly, different studies have shown that hydroclimate of the Awash Basin changed based on rainfall simulating satellite data. Therefore, assessment and quantification for the hydroclimate change is essential in water resource planning and management. It is a fundamental motivation for us to investigate the relationship between the climate and water resource. Accordingly, this study aimed to assess the basin's hydroclimate change and existing climate concerning the topographic classes. So when we see the location, this basin is basically exists in the middle of the country, where Addis Ababa, as I told you, Bishoftu town, Adama, to the downstream are existing. So it has about 11,402 kilometers square on coverage. The variation of the elevation ranges from 3,000 to 1,600 meter above mean sea level. These are stations in the basin that we consider for the study. Locations are there, elevations. So here what you have to see is what we consider the missing data during our study time for 25 years. See the time range between 1991 to 2015. So as a method, the basin daily hydroclimate data element for 25 years were collected from 11 meteorological stations that I have shown here. 7 stream flow stations subjected to statistical evaluation. The primary data analysis starts from the central concept that the climate change is possibly manifested in difference in precipitation resulting in stream flow regime change. Thus, the data discrepancy test was considered because this may happen during the recording time or with an instrument, and it can emerge from different sources. So filling data gaps was done, homogeneity test to see the autocorrelation. This is also very important to see the data consistency for the proposed statistical application. Considering the statistical application, Mankandel and Sunslope statistical test was considered. Why we use this? Mankandel and Sunslope are basically statistical approach that applied for hydrological processes. Traditionally, the climate of the basin has 4 seasons. Arfasa refers to spring, March to May. Ganna is summer, June to August. And Birra is autumn, September to November. And Bona is from December to February and is called winter internationally. The basin stream flow trend evaluation was performed within Awash Hombolle and Mojo main tributary. 2 main tributary are considered. To maintain data and consistency, mixed data filling method is employed and homogeneity test, another process used under the consistency of data. Another approach we used is systematically classifying the topography into 3. Why we use is, you can see here the location. The outer part is island. This is a midland and the lowland. So the flow direction was to one direction, and it is from highland to lowland, from high rainfall concentration to low rainfall concentration up to the Koka. Koka is also, it has its own history in this country. So according to our classification, the first class was from 1,577 to 1,990. The midland is from 1990 to 2,250, and highland area. The highland area is 2,250 to 3,400 meters above mean sea level. The regression analysis was done. This study detect the basin's hydroclimate trend concerning its topographical classes, correlation that relapsed with a multiple linear regression method. According to the equation 11, the simple linear regression calculation and consider topography to precipitation correlation. What's the correlation between the topographic locations that we systematically classify and the existing precipitation? We use this method, and after evaluation of everything, after we collected data and fill the gaps and correlation analysis and data consistency evaluation, and systematically we classify highland, midland to lowland, and from our tributary we use two main rivers, Awash Ombole and Mojo River, the two outlets that feeds downstream. So multiple linear regression of evaluation for temperature and precipitation to evaluation. Elevation to temperature and precipitation to elevation correlation was performed. From the systematic evaluation classification basin, the lowland had about 361 mm in average. This is mean annual precipitation. Midland got 354, and highland had about 137 mm. So we saw the difference in annual mean temperature precipitation. When we come to meteorological trend analysis, the basin had 1019 mm mean annual rainfall. The maximum was 1340 and the minimum was 873 mm, which was recorded during 1993 and 1997 respectively. The maximum rainfall was recorded in 1993 and the minimum was in 1997. Since Arfasa, Ganna and Bra are agricultural time, very important we consider those. Lowland, Bishoftu, Mojo and the Hombole stations displayed an increasing hydroclimate trend, both seasonally and annually. We can see here, the increasing trend was exhibited. They had an annual significant increasing trend with 95% of significance level. Hombole and Mojo stations that contribute 31.22% of the basin precipitation had a significant seasonal rainfall growth, except for Bra season. Bra means autumn. Of Mojo, the Bishoftu station had a significant hydroclimate rise seasonally and annually during a steady time that we saw. Bra season of Mojo experiences rainfall and temperature increasing by 95 and 90% of significance level. When we come to Midland, Sabata, Kemoye, and Ginchi, Asgori is there, stations that accounts 34.28% of precipitation of the basin had decreasing seasonal precipitation. Annually, Sabata station significantly increased. So we can see here the Midland, a decreasing trend observed. Annually, the maximum temperature of Kemoye and Asgori station increased, while Sabata and Ginchi station decreased. That means a fluctuation.
1 minute left.
Okay. So precipitation of highland exhibited decreasing trend annually in Arfasa season. Again, during Ganna season, Adsalam and Sawa increased significantly. So highland station exhibited increasing trend annually in all seasons. This is the contribution maximum, minimum, and standard deviation of the season. And seasonal and annual stream flow evaluation. We come to evaluation. The basin receives two rivers. I told you earlier, Awash Ombole. So this is Awash Ombole and this is Mojo stream flow. This is what it exhibits. Hombole decreasing trend. Mojo is also decreasing, and totally the basin got the decreasing trend in stream flow. From linear regression, the result shifts of stream flow except for mean annual during 1996. So these are when we see the correlation between rainfall and the stream flow, this is also obvious. So it fit out with our concept, the first concept we come with.
Okay, time's up, Mr. Fekadu.
Okay, 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 okay. Thank you.
Okay, thank you very much, Mr. Fekadu, for your presentation. I think because the limited on time,
Yeah.
we can continue. So we discuss let's start with discussion. Any question for Mr. Fekadu? Is there any question? No? Maybe I ask about your conclusion from your research, because you not
Oh,
stated
okay.
yet. This is your
Yes.
chance to explain about your conclusion about your okay.
Okay, okay. Yeah. Okay. As a conclusion, there's a correlation between hydroclimate within a hydroclimate elements. A negative correlation between elevation and temperature is observed. In the highland area got 35%, the midland 34, and 31 was basin's precipitation. The result of highland area meteorological evaluation shows that increasing trend for precipitation and decreasing trend for temperature.
Oh,
The Ganna season, very important season. Addis Ababa, Addis Salam, the highland area got seasonal and annual decreasing trend, but that is unexpected, basically. Midland exhibit decreasing trend in precipitation. The lowland also, but contrarily, the lowland increased with the precipitation, except the dry season. That was very fun. Dry season, the dry area, the rare area increased and the wet area decreased. So our Shumbulle sub-basin, that means decreasing trend because of the precipitation is decreasing from highland, and precipitation of basin increased as whole because the midland and the highland and the lowland increasing trend is observed. The rest 30% of the exhibited decreasing trend, while 30% of steady station decreased. I mean increased, sorry.
okay. That's all?
Yeah.
Okay. Thank you very much, Mr. Fekadu, for your presentation and your explanation about the hydroclimate trend analysis
Yes.
at Ethiopia. Okay.
Yes.
Okay, thank you very much. And we will continue to the next presenter. Maybe I would like to call Mr. Iwan Setiabudi, still not here. Okay. And then Mahawan Karuniasa. Mr. Mahawan Karuniasa, also not come yet. And then the next presenter, Hailu Gisa Kuma. Mr. Hailu Gisa Kuma. Not joined yet. And then Mr. TKB Kuma.
Yes.
Okay. Is it okay if you present early from your schedule? Okay. Okay. I think you can start now. 12.
Is it okay?
Is it okay? Is it okay? Slide and your voice okay clearly. You can.
Hello everyone. My name is Taka Bekuma from Kollega University, Ethiopia. First of all, I would like to express my heartfelt thanks to organizers of this important conference on important issue. So saying this, I am going to present variability and the trends of climate in East Wallagga Zone, Western Ethiopia. As a background, global climate change is a burning issue, burning and a current issue, and will continue in the future if appropriate measure will not taken. Human activities contribute to climate change by causing increased greenhouse concentration in the atmosphere. In developing country, including Ethiopia, agriculture is backbone of economy, wide growth. So the relationship between climate change and agriculture is two-way. Agriculture is the cause for climate change through emission of greenhouse gases, and climate change also affect agricultural productivity. So also there will be gains in some crops in some regions of the world. The impact of climate change will be expected to be negative. So Ethiopia is among the countries that are most vulnerable to climate variability and the change, and the frequently faced droughts and the flood. In Ethiopia, agriculture is the foundation of economy on which the livelihood of the population is fully dependent. The smallholder farmers are engaged in subsistence rain-fed agriculture characterized by low agricultural productivity and food security in Ethiopia. So climate change combined with low adaptive capacity and widespread poverty aggravated food security risks for rapidly growing population. As a result, the future of food security is questionable due to increased impact of climate change and the need from the rapidly growing population. Studies on climate need to be locally and nationally relevant for research results to be used. So in Ethiopian case, climate change research is limited, and in most cases, it is none at local level. Therefore, this study aimed to fill this gap by analyzing trends and variability of the climate. Objectives of the study. The overall objective of the study was just to explore variability and the trends of climate in East Wallagga Zone, Western Ethiopia. Specific objectives to determine trends of rainfall and the temperature, to examine temporal variability of temperature and rainfall, to identify the relationship between climate variables, that means the relationship between temperature, rainfall with time. Materials and the methods, data types and the sources, historical climate data, temperature and rainfall for 37 years collected from National Meteorology of Ethiopia, analytical materials, Mann-Candle trend test, sense slope estimator test, linear regression model, coefficient of variation were employed for data analysis. Sorry. Yeah, results and the discussions, trend of monthly, seasonal, and the rainfall. Monthly, seasonal, and annual rainfall observed a decline trend. That means it's just a decreasing trend, except for May, November, and the spring. The trend was statistically significant for August at 5% significant level. The same slope also showed a declining magnitude in rainfall. Trend of monthly minimum and the maximum temperature. Monthly average minimum and the maximum temperature showed a warming trend. That means increasing trend. So since slope also showed presence of positive magnitude for both maximum and the minimum monthly temperature. Trend of seasonal and annual temperature. An increased warming trend has been detected for seasonal and annual temperature, seasonal maximum and the minimum temperature. The trend was statistically significant for both seasonal and annual maximum and the minimum temperature, except for winter minimum temperature. Relationship of annual rainfall and the temperature with time. there was no statistically significant relationship between annual rainfall and time at 95% confidence level. A statistically significant relationship has been detected between annual minimum, maximum, and the mean temperature and the time. Relationship of seasonal rainfall and the temperature with time. There was a statistically significant relationship between seasonal rainfall. Between seasonal minimum and the maximum temperature with time at 95 confidence level. For seasonal rainfall, there was no statistically significant relationship. Variability of rainfall. The variability of monthly rainfall was moderate for months of July and September. And it is high for the remaining, the variability of rainfall is high for the remaining months. The seasonal variability of rainfall was moderate for summer and autumn, while it was high for spring and winter. Annual variability was is moderate. Variability of temperature. The variability of monthly minimum and the maximum temperature ranges from stable to moderate, except for December minimum temperature, which exhibits extreme variation. Seasonal maximum temperature was stable for summer, autumn, and it is moderate for winter and spring. Seasonal minimum temperature was stable for spring and the summer, whereas it is moderate for winter. Annual maximum, minimum, and the mean temperature was found to be stable. Conclusion: the study area is vulnerable to climate variability and the change because of largely depending on rain-fed agriculture, widespread poverty, and a low adaptation capacity. The result of the study found that monthly, seasonal, and annual rainfall showed a declined trend except for May, November, and spring. Maximum, minimum, and minimum temperature revealed a warming trend. So generally, the rainfall shows a declining trend in the area, and the temperature is showing a warming trend in the area. There was no statistically significant relationship between monthly and the annual rainfall with time. There was a statistically significant relationship between maximum and the minimum temperature with year, except for winter minimum temperature. There was a statistically significant relationship between seasonal temperature and time. Monthly, seasonal, and annual rainfall variability ranges from moderate to high. The variation of monthly, seasonal, and annual minimum and the maximum temperature ranges from stable to moderate. Based on these findings, the following recommendations were forwarded. Here, decisions regarding cropping system and the planning adaptation in the area is better to take into account declining in rainfall and the increasing temperature. Even so, climate systems are very highly complex. The current study employ only temperature and rainfall. Therefore, future studies better to consider additional climate variables for more detailed study in the area. Finally, I want to thank Wellagga University and Sebelas Maret University for the opportunity. Thank you very much. Thank you.
Okay, thank you very much for Mr. Teka Pekuma for your presentation. Okay, let's start with discussion. I think we have one chat for you. I think this is good. Good suggestion. Mr. Veda Sabendi, Mr. Veda Sabendi said that we couldn't find the analyze either in table or in figure. I think Mr. Teka, it's better to explain your presentation, the result especially in the discussion with figure or the table, so all the participant can understand about the figure and the table to make analysis. And then, is
Shall I
there
respond?
any? Okay. You can respond.
Okay, in my main document, there is tables and the figures. This is why, the amount of slide is very limited. And this is why I haven't included in this presentation. Otherwise, in main document, there are different figures, tables, very well, it is included in the document.
Okay, thank you for your response.
Okay.
Okay, is there any other question for Mr. Teka Bekuma?
Yeah, may I ask him?
Okay, one last.
Okay, what is the basic background that the climate variability around West Wallaga that he present? What is the background? That means what is a contributing factor as he believe it? Thank you.
Okay, Mr. Teka Bekuma.
Okay, thank you very much. As you know, the area is just largely depend on rain-fed agriculture. Here in the area, agriculture is just affected because of variability in climate change. This variability may be expressed in terms of delaying in rainfall, early cessation, and extreme events such as flooding and the drought, a frequent drought occurrence of this extreme events. We can express through this variability.
Is it okay, Mr. Vegadu?
Okay, leave it. But I need what is the basic for variability of that climate? The climate is variable, I mean variated. What's the basic for that variability? That was what I need.
Okay. Mr. Teka Bekuma, can you?
Yes.
Maybe you can answer in the by texting or
Yeah, thank you.
another email.
Yeah.
Okay, because
Okay.
the limitation of time. I think.
Yes. Even he can
sorry,
share us a link.
I think as there is other questions. What is your base? Which says what is your base for classifying variability? This is based on research, okay, on published documents. My base for classifying variability of rainfall and the temperature is just I based on published.
I'm sorry,
papers.
Mr. Tekuma, I must control this. Okay, because the limited time. Maybe we can continue the discussion in another session. Okay. I will close this Mr. Teka Bekuma session. I will continue to the next presenter. I would like to invite Mr. Hailu Gisa Kuma to present. Are you ready? Please unmute your mic. Okay. Maximum 10 minutes for your presentation, 2 minutes for discussion. Okay. Mr. Hailu Kisakuma, can you hear me? Mr. Hailu Kisakuma? Mr. Hailu Kisakuma, can you hear me? Are you ready to present your presentation? I can hear your voice. I'm sorry, I cannot hear your voice. Mr. Hailu Kisakuma, are you there? Can hear me? I'm sorry, I cannot hear your voice. Maybe another another participant also cannot hear your voice also.
Can I continue?
Okay.
Hello?
Okay. Hello. You can
Hello, hello.
continue your presentation. Now, okay, your voice. We can
Hello?
hear your voice. Hello.
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 Yes,
Hello.
yes, I am
Yeah.
hearing you.
Okay. You
Can
can
I con-
continue. You can start your presentation.
Okay, my presentation title is Local Climate Change Indications, Historical
Maximum 10 minutes.
Trends.
Okay.
Okay, multimodal projections and the implications in Black
Please,
catchment.
your slide.
Okay. Okay.
Not appear yet.
Ay, samang yan. Ay, ba't gidiso? Gitaya na. Eko. Hello?
Hello. Okay.
What about now? Are you hearing?
Yes, I'm hearing, but your slide. Okay, your slide is appear. Okay.
Okay, I can continue.
Okay, you can continue. 10 minutes maximum for your presentation.
Okay.
Please.
Again. Okay.
You unmute again your microphone. Please unmute your microphone. Mr. Hailu Kisa, are you there? Mr. Hailu Kisa, are you there? Mr. Hailu Kisa? Mr. Hailu Kisa, are you there? Mr. Hailu Kisa? Yes, no sound from Hailu. Please unmute your microphone, Mr. Hailu Kisa.
Okay, climate.
Okay.
Okay. It's ready. Climate change is dependent in weather events, human effects on climate structure, according to these scholars. Its impact is reformed the hydrologic system, affecting water resource and agricultural production. In East Africa, frequent droughts. Due to this reason, climate models were developed to indicate change and respond adoption strategies. And different climate models developed, like regional climate models. So individual and the ensemble means of regional climate models employed, and ensemble means executed better. When we see tendencies of temperature and the rainfall in Ethiopia, February to May and the June to September, rainfall decreased by 15 to 20% in mid-1970s and the 2000s. So another study by Tashome and Zhang, decreasing annual rainfall totals and increasing temperatures observed. So my study catchment, Blatte catchment, there is rain-fed and subsistence agriculture, which could be affected by climate change. So local climate change study is very important instead of national chorus level study. So the major objective is evaluating local climate change indications. Specific objectives are analysis of historic rainfall, temperature trends, climate change, and the characteristic of heat waves and dry and wet months. So for our study, the materials of the data used are time series climate research unit data from SEDA, historical climate data from National Meteorological Agency of Ethiopia, and regional climate model from Cordex Africa. And the methods used are accumulated anomalies were estimated by Lozecki equation, trend analysis by Mann-Kendall, magnitude of trends by Tellsen estimator, and climate change projection by using regional climate models ensemble mean. From this, temperature and the rainfall derived or projected. From this, heat waves were derived from maximum temperature by R package, and normal, wet, and dry months were calculated by SPI by R package. Let's come to result. Historical accumulated anomalies and the trends for both CRU and observed rainfall, the changing points and variation in slopes were detected as the figure. So rainfall, for example, changing points are exactly equal with 1986, 2008, and 2011 for both CRU and observed. So the increasing trends and the decreasing trends are observed. CRU and observed maximum and the minimum temperature, both featured upward and downward slopes. Maximum temperature has highest positive deviation from mean after 1999, and the minimum temperature after 2002. So the warmest years have all come in 2000s and 2010s, and this indicating featuring of warming in the catchment, and it also showed featuring of climate change indications in the catchment. When we come to regional climate model projections, projection of maximum temperature for 3 future periods under RCP 4.5 and 8.5 relative to the base year 1981 to 2010. When we compare this century and this century with the baseline, for example, Blatte catchment under both RCPs increased in Boditi, Halaba, Hosanna, all. So during this century, the maximum temperature at Halaba featured 1.2 degrees centigrade. Let's come to over Blatte catchment in mid-century. In all representative locations, temperature has increased from 0.3 to 1.9 and 1 to 2.6 under 2 emission scenarios. In the century, 0.3 to 2.4 and 1.4 to 4.2 degrees centigrade under 2 RCPs. So when we compare it with this century, maximum temperature has got increased up to 4.2 degrees centigrade. So when we see the projection of minimum temperature, the same is true. Minimum temperature featuring increasing in all 3 periods. So the end century are likely to become warmer than those in this and the mid centuries. So projected temperatures show steady increase, and this study is in line with studies by Houghton, MC Sweeney, and so on. When we come to projection of seasonal rainfall, the rainfall featured an increasing and decreasing trends and the two scenarios. So the first one is increasing from 124 to 3,009.9 millimeter and 52.1 to 1,111 millimeter under two RCPs. The decreasing rainfall shows negative 1.4 to 1,629.5 millimeter and negative 247.3 to 2,000 negative 2,000.
1 minute left. Okay.
Okay, highest rainfall declined by this amount and at Alaba under RCP. And anyhow, we can say that decreasing seasonal rainfall is more pronounced over the catchment. So short rainy season, February to May crop of 2021 was failed due to decline in rainfall in the catchment this was stated by Kuma et al. When we see future dry months under RCP 4.5 on January 13, 12, and 11 at Halaba, Boditi, Belate, and Hosana respectively. On February month 6, 5, 4 at Belate, Halaba, Boditi, Hosana respectively. Dry months are also progressively increasing. This can affect crop production in the catchment. When we see future heat waves, daily maximum temperature of regional climate model ensemble was employed.
Time's up. Okay.
Time's up?
Yes. I'm sorry,
Okay.
because
Okay.
too many problems in there.
Okay.
Okay. If there any question to Mr. Hailu? Any question? Okay. If no question, I will ask about. I wonder how many seasons in Ethiopia actually? 2 seasons, 3
Yes.
seasons, or
Yes, 4 seasons.
Four
No, yes,
seasons.
3 seasons. For 3 seasons of 4 months.
or 3 seasons with 4 months?
Yeah,
Oh, yeah.
no, 4 months in 3 seasons.
Or 4 months in 3 seasons. What are the seasons?
The first one is from February to May. That is called Balg in Ethiopian language. And from
Okay.
July to September, that is Kramt rainfall. And
Rainfall,
then,
okay.
yeah,
July to September.
the third one is from October to December, no, February. That is the dry season called Baga.
Baga, okay.
Yeah.
What
Of this, agricultural practices are taking place in the first one and the second one.
first one, second one for agriculture. So the only 8 months for agriculture. Okay.
Yeah.
Okay. Very interesting, because in Indonesia we have 2 seasons. I think.
Okay.
Dry and wet season. Okay.
Okay.
Okay, thank you very much, Mr. Hailu, for your nice presentation.
I ask you, excuse me, I interrupted with net connection.
Okay.
Okay. Thank you.
Many countries have
Okay.
problem also.
Okay. Thank you.
Thank you very much. You're welcome. Okay.
Okay.
I think we can continue to the next presenter. Actually, I want to invite once again, Mr. Iwan Setia Budi. Not appear, not joined yet. Mahawan Karuniasa also not joined yet. And in this session 1, I think the last presenter will be Miss Arvita Rahmawati, who will present the title Raster Correlation Method for Vegetation Density and Surface Temperature in Kupang City, Indonesia. Are you ready, Miss Arvita? Please unmute your microphone. Okay.
Yes. Yes, I'm ready.
Okay. Now, time is yours. Please in 10 minutes maximum. Okay.
Okay, thank you, moderator. Good afternoon, ladies and gentlemen. Today, I will present my research with the title Cluster Polarization Method for Vegetation Density and Surface Temperature in Kupang City. Let me introduce myself first. My name is Arvita Ramawati and my partner Bella Theotomi Pamungkas. We are from Geographic Education Department and Nusa Cendana University. Okay, next. Okay, next. Anyone can hear my voice?
Yes. Okay, your voice clear. Okay.
Excuse me, anyone? Okay.
Okay.
Okay,
Clear.
thank you. So let's the introduction. The phenomenon of urban heat due to global warming that occurs in almost all cities in Indonesia is a microclimate phenomenon that can't be avoided. Microclimate issues are an important factor in sustainability within cities. The phenomenon urban heat increases the ambient temperature significantly. So Kupang City is a semi-arid area with a significant difference in duration, rain 3 until 4 months, and dry season 8 until 9 months. With a small duration of rainy months, this will have an impact on the urban heat phenomenon. Okay, next. Based on the problem above, the study need to identify the effect of change in vegetation on surface temperature in Kupang City. It can see the vegetation density change from previous few years and the extent to which the presence of vegetation affects the surface temperature of the area, as well as providing input and information to the Kupang City government and related institutions on how the vegetation density and surface temperature are presented in the form of a map between 2010 and 2015 and 2020. So the local government makes attention to the environmental condition of Kupang City, in particular, especially to provide important information of the existence of vegetation. Okay, next slide. This is the method. Sorry, I get the wrong written. First, Landsat. We use data Landsat ETM Plus for data 2010 and Landsat X only satellite image 2015 and 2020. So after that, we're doing a Landsat satellite image correction, such as geometric correction and then radiometric correction and then panchromatic correction. After that, we cropping with the administration map. For vegetation density, we use NDVI. NDVI is, or we call it normalized different vegetation index being red, infrared band. So the result is vegetation density map. For the surface temperature map, we use mono Windows brightness temperature algorithm using radiant spectral from digital number. So from to map with the using Fisher net to take a sample from DN or digital number each raster. So that's why I call this raster method correlation. We use correlation and then correlation vegetation density and surface temperature. Get it from the correlation. Okay, next. Okay, this is the results from the NDVI. We can see the dominant vegetation in 2010, medium vegetation with next from the figure we can make a table. So can we next in the table? Admin, can we next? Okay, this area of vegetation density in Kupang City, we can see from the dominant vegetation in 2010 is medium vegetation with area 7,391.25, and in 2015 and 2020 the dominant vegetation is low vegetation. As we see, the low vegetation is grass and bushes. So in medium vegetation is such as the vegetational cover, like as of coconut plantation and mixed plantation. So next. So is the surface temperature. As we can see, the vegetation density, raster temperature. And next, I'm sorry, that's got wrong to write the title. It's surface temperature in 2010 and 2015 and 2020. Next, from the figure, we make a table. Admin, can next, please? Okay. As we can see, in 2010, we can see that the range of surface temperature is 26 until 28. And then in 2015, become this rise from 26 until 2018, become 29 until 31 degrees Celsius. Okay, we can next, please. This is the raster correlation vegetation density and surface temperature in Kupang City. From figure T, the evaluation can see generate with an effect 18% in 2015. The equation was generated with effect 9%, and in 2020 the equation generated with effect 17%. From the three equation we can see regression coefficient is negative, so that means the two parameters are inversely proportional. Okay, next. So the conclusion, the dominant vegetation density in 2010 was a medium vegetation class, such as vegetable land cover was in form of coconut plantation and mixed plantation. Then the dominant vegetation class in 2005 was a low vegetation. In 2020, same as 2015, is grass and bushes. I'm sorry, this my the surface temperature is average. The surface temperature is 14.67%, and the coefficient correlation value is negative, meaning that the denser the vegetation, the lower surface temperature. Okay, next, admin. Okay, thank you. Thank you for your attention.
Okay, thank you, Ms. Arvita. That's all for your presentation. So let's start with discussion. Is there any question?
I see in the chat any question from Fekadu Adu, Mr. Fekadu.
Okay. Okay. From Mr. Fekadu Dukuma asking what type of band combination used. The image type and band combination is the most important to map vegetation with temperature. Can you answer the question, please, Ms. Arvita?
Okay. Okay, thank you, moderator. Thank you, Mr. Fekadu. For in DVI, in Landsat 7, I use band near infrared, band 4, and red band using band 3. That's for NDVI in Landsat 7. But for Landsat 8, I use near infrared using band 5, and red band using band 4. And from surface temperature in Landsat 7 using band 6, in Landsat 8 using band 10. That's the answer.
Okay, Mr. Fekadu, on the answer? Okay, yes, I think. Is there any question? No question. Okay. If no question, I think we can close for this presentation. I think thank you very much, Ms. Arvita, for your presentation and your answer for the discussion session. Okay, this is the last presenter from my session or session one. Actually, I invite once again Mr. Iwan Setiabudi. Okay, I think, and also Mr. Mahawan Karuniasa. I think both of them cannot can join this session. And okay. Okay, I think that's all for this session presentation. I will close for the session one presentation. I would like to extend my gratitude to all speakers, presenters who already giving good and nice presentation. I believe this this event or this session, your presentation will be beneficial for our future. Thank you very much, and I close. Alhamdulillah. Assalamualaikum warahmatullahi wabarakatuh. See you later in the next event or in the next session. Thank you.
Thank you.
You're welcome.
afternoon, everybody. I already joined this room. We will begin on 3:13, right? 3:15. Good afternoon, everybody. Can I start this session? Is still take rest? Or all of you are ready to start the session? Okay, some of you already open the camera. Okay, I will start this session. Good afternoon, everybody. Let me introduce myself. My name is Sutresno Hadi. You can call me Sutresno or Hadi, is okay. And I am from 11 Maret University, especially from Department of Animal Science, Faculty of Agriculture, 11 Maret University, and the committee invited me to become a moderator in this room. Okay, welcome to this 7th International Conference on Climate Change. And welcome to the room 1 and then session 2. And hope you enjoy this session. And before we start the presentation, I will check the availability of you as a presenter according to the list from the committee. Please, you can say yes if you are available here. Okay. The first one, the presenter, the first presenter, Keigo Noda, are you here?
Excuse me, I'm on behalf of my professor Keigo Noda. So yeah.
Okay, thank you. The second, Abdul Rahman Ashukur, are you here?
Yes, I'm here. I'm on behalf of my lecturer.
Okay, thank you. Ibrahim Jahanshiri.
Hi everyone. I'm on behalf of the Ibrahim.
Okay, thank you. And Feda Sabintu. Feda Sabintu. Not available yet. Okay. And Afnur Imshah. Are you here? Afnur Imshah. Okay. And next, Ifunanya Rita. Ifunanya Rita? Not available yet. And then Purwa Edi Minarno. Purwa Edi Minarno. Okay. Maybe not available yet, but no problem. I think we can start.
Excuse me,
the first. Oh, yeah.
Mr. Moderator, I'm here, Afnur Imsa. Sorry.
Afnur Imsha.
Okay.
Okay, Afnur Imsha. Okay, thank you. Okay. So, according to the rule from the committee that every presenter have the duration around 12 minutes, include presentation and discussion. And we suggest to the audience here, the person who not present, we can give the question in the chat box Zoom first, and then after that, if you want to speak directly, you can on mic. But if enough, you deliver the question in from chat box is okay. And yeah, and depend on you. I think you divide the 12 minutes, how many time, how many the minutes you can manage yourself. Yeah, maybe 8 minutes for presentation and 4 minutes for discussion, or maybe 10 minutes for presentation and 2 minutes for discussion is okay. Depend on you. Okay. Yeah. Okay. Thank you. So I invite the first presenter here to give the presentation of the paper. Is Keiko Noda. The title is Decision Making in Climate Change Adaptation through Cross-Sectoral Approach Review. Okay, time is yours.
Thank you very much. Good afternoon, everyone. My name is Astha Lamisane. I'm from Nepal and currently studying Masters in Applied Biological Science in Gifu University. First of all, I would like to thank the entire committee of the ICCC conference and also my respected Professor Keigo Noda for providing me such opportunity to present in front of you all. So today I'm presenting a review article in which I have worked as a first author, and the article is entitled as Decision Making in Climate Change Adaptation, CCA through a Cross-Sectoral Approach. Next slide, please. Yeah, decision making in climate change adaptation is a very complex and challenging topic in which there are various economic approaches that are being used in climate change adaptation decision making. Those approaches are cost benefit analysis, cost effective analysis, multi-criteria analysis, and various other approaches within those within these three approaches as well. A proper decision-making tool is very vital in adaptation planning, and it should consider all the factors such as the region, climate, environmental, social, economical, and political conditions. And the derived adaptation options should be locally acceptable, practicable, and reliable. So the major target of our review article is to focus on cross-sectoral approach that has been used in various parts of the world that consider not only monetary value, but also the qualitative aspects within the adaptation planning. Next slide, please. So in this review paper, we have chosen a multi-criteria analysis tool that has been adopted by previous literatures. So the basic reason for us to choose MCA is that MCA is a participatory, systematic, and a structured tool which can assess both qualitative and also the quantitative data, and also involve experts and stakeholders for prioritization of
Hello, is it connection problem? Stop. Problem with connection, my connection, or the presenter connection? Hello, the other person.
The slide not move, moderator.
Okay, maybe. Hello.
Hello, can you hear me?
Hello, Ms. Purdy. Oh yeah, yeah. You just
I'm
join
really,
again.
I don't know, like Wi-Fi connection is being attacked this
Okay,
morning.
okay,
So yeah, I'm really sorry. So I would
okay.
like with the presentation.
Okay,
So
continue.
yeah, in this review paper, we have chosen multi-criteria analysis tool for the overall review of the previous articles. Next slide, please. So the major aim of this study is to study about the past applications of MCA in different fields across diverse regions of the world, and to analyze criteria required for developing adaptation strategies in different scenarios. The major area of focus of this review article are climate change adaptation in agriculture, water resource management, and flood risk management. Next slide, please. So we have adopted a systematical review method by applying a PRISMA method, which is also known as preferred reporting items for systematic reviews and meta-analysis. And from PRISMA method, we have, from Scopus, we have discovered about 383 articles, from which 51 articles are included in this review, and 33 articles are listed as shortlisted case studies. Next slide, please. So from the shortlisted case studies and also from the result of the PRISMA method, we have come across several publications, and also we can see in the figure number 3 that the number of publication regarding climate change adaptation in by applying MCA has been increasing since 2011 to 2016, with some fluctuations in 2012 and 2017 and 18. And also regarding the publications in 2021, as this review paper considers the publications until June, the publication of 2021 is already 14. That means about 63% of the whole year, which is also a remarkable point. So 33 case studies are shortlisted, and they are also arranged according to the year of their publications. Next slide, please. So now I would like to talk about shortlisted case studies based on continents. Overall, 35% of the articles were published from Europe, and also followed by 34% in Asia and 16% in Africa, whereas South America and North America were South America and North America showed a minimal number of publication which were eligible for our studies. Next slide, please. So figure number 7 shows the shortlisted case studies based on area of focus. As I already told, our area of focus was our agriculture, water resource management, and flood risk management. For overall agriculture and water resource management, each 26% were the most researched sectors, followed by 24% by flood risk management, and also few articles were scored their research objective as a mixed by combining agriculture, water, or spatial planning also. Next slide, please. So in the figure number 8, I have listed the shortlisted case studies based on the methodological approach. The methodological approach of MCA and also other combined models are included in the review paper. So overall, 16 articles adopted the solo MCA as their only methodological approach, followed by AHP, which is also known as analytical hierarchical process, and also some other combined models like WIP model and also SWAT model was seen. ASP combined with GIS and remote sensing technology was also used in flood risk assessment in many papers. Next slide, please. So moving towards the discussion, the review paper revealed that the global focus has been slowly shifting towards adaptation planning from the previous trends of impact assessment and mitigation plans. In recent years, MCA has been excessively used in the sectors of water resource management, agriculture, and flood risk management due to its diverse nature in deriving adaptation options. In the context of least developed countries as well, MCA seems to be more effective as it can consider all the holistic nature of the least developed countries, like the economic and the social and the political factors. Next slide, please. So as mentioned by Cornell et al. 2020, there are 4 qualities that should be considered in adaptation planning, that are effectiveness, efficiency, transparency, and legitimacy of the adaptation options, and also 3 questions that are very important while planning those options, that are what to adapt, how to adapt, and who adapts, and also regarding the combination of the different kind of models with MCA, combination of top-down and bottom-up approach could be also an option, as told by Bob et al. 2014. The evaluation of exposure and vulnerability prior to strategy development is also an important step in adaptation planning, where simultaneous coordination between scientific groups, researchers, technical experts with the concerned stakeholders play a vital role in formulating the adaptation options. Next slide, please. So as climate change is unpredictable, there are multiple future vulnerabilities and future uncertainties that should be linked while planning for adaptation options, because the adaptation options are ultimately for the future goals. So there are various uncertainties linked with climate change, that are biophysical uncertainties, hydroclimatic uncertainties, and also socioeconomic uncertainties. So in order to address all these uncertainties, MCA is kind of lacks in addressing all those by its solo application. So an integration of technical, social, and institutional aspect could combat the constantly evolving climate and climatic variabilities. Also incorporating some methods like sensitivity analysis and other methods like dynamic adaptive pathways, real option analysis, robust decision-making analysis, etc. could boost up decision-making processes in climate-sensitive sectors, as told by authors as mentioned in the slides. So the combination of top-down models like hydrological modeling, GIS, WIP model, remote sensing, and other spatial analytical model could also help in combating and addressing those uncertainties, where the theory of compensability helps to overcome the shortcomings of one another. Next slide, please. So to conclude, a holistic adaptation strategy development and planning requires considerations from broader view of future changing variabilities, and also consider about the future possible maladaptations regarding the adaptation options. As seen in the figure number 9, the adaptation planning and adaptation strategy in general combines all the factors as listed in this slide, as like consultation with experts and stakeholders, along with combining qualitative and quantitative data, technical, social, and institutional aspects, considering about future uncertainties, maladaptations, and also exposure, vulnerability, and risk assessment and also assessing economic feasibility, and incorporating combined models could help to make and design a holistic adaptation plan. So for a sustainable adaptation planning, it should be reliable, economically feasible, and applicable in social aspects. So to conclude, I would like to say that from this review article, we came across that to attain environmental sustainability and also social acceptability, the adaptation planning should be holistic and also consider several factors of society and also climate. Thank you very much.
Okay, you finished? Okay, thank you. Thank you for the presentation, Ms. Keiko Noda. Maybe any question from the audience? Okay. No question? Yeah, I think this is the study is about using the meta-analysis. Yeah, using meta-analysis is complicated. I think.
Yeah.
Okay.
Yeah.
Yeah, and you are using 383 articles. So how do you select for the huge article in the world that you can choose 383 articles from your study meta-analysis?
Yeah, actually, the initial assessment was based on the titles, abstract, and introduction, and further there were eligibility criteria that were set up for our review article, and based on that process, we assessed, we sort out kind of the numbers, and there were like out of 383 articles as well, there were multiple duplicate articles which were republished maybe. So yeah, they were also excluded, and yeah, it was a long run.
Yeah. Yeah, so you have some criteria for the article that you want to use at the data from your study.
Yeah.
Oh, okay. Okay, any question from audience? No? Okay, congratulations for Keiko Noda. No question for you. So I think because time is limit, so we going to the next presenter, I think. Thank you for Keiko Noda. And the next presenter will be Abdul Rahman Shakur. Please, time is yours.
Okay, I would share screen my presentation. Okay.
Yeah, okay. So you share yourself?
Yeah.
Okay,
myself.
good. Yeah.
Okay. Okay, can you see my presentation?
Yeah. Can
okay. Hello everyone. Good afternoon. Let me introduce myself. My name is Iputu Winston Putra Arsana. I am a bachelor student of marine science at Marine and Fisheries Faculty in Udayana University. So I would like to present my research. The title is the Urnal Rainfall Cycle.
Sorry, you not upload your PPT in the GFOM?
Yeah, the committee said I will share my presentation by myself.
Okay.
Yeah. So the title is the diurnal rainfall cycle on small tropical island as seen by the 20 years half-hourly GPM IMERT satellite precipitation product. Okay, we can next to introduction. Okay, the first is Indonesian diurnal rainfall. Indonesia is a tropical region located at the equator and has maximum rainfall and sunlight. Solar activity and wind patterns affect rainfall pattern in Indonesia. Rainfall over Indonesia is strongly influenced by monsoon climatic condition, which result in clear difference between wet and dry seasons. The pattern and distribution of rainfall in Indonesian Maritime Continent or IMC influenced by the diurnal rainfall of cycle. And then Indonesian Maritime Continent or IMC area as the shape of the island, the topographical condition and the shape of the coastline cause the diurnal cycle of rainfall to be inhomogeneous for all regions. And then next, diurnal rainfall affected by topography. Different topographic characteristics in some region will affect the air temperature, which is related to the evaporation rate in making cloud and producing intensity of rain. Characteristic of the diurnal rain cycle in mountain area will show a different pattern with a lowland areas. Mountain area as physical barrier to the movement of rain. Different form of straight and concave coastline have a different characteristic of diurnal rainfall. On the shoreline with a concave shape will produce high rainfall in the ocean because the shoreline with a concave shape has a convergence of onshore wind that is preponderant than the straight shoreline. Okay, next. We can move on to material and method. The first is time and place. This research was conducted on the island of Bali by looking at the distribution of rainfall during 2001 until 2020. The location is chosen to see the distribution and movement of rain from Ore to Bali, as shown in the presentation. Bali has a mountain range that divided into two parts of watershed that affect the north and south has the different rainfall as shown in presentation. The location was chosen as a representation of condition of one of tropical complex small island in the Indonesian Maritime Continent, or IMC. Okay, we can win next in the material and method. So the data used is obtained by downloading from the https://this.gsfc.nasa.gov site, which is in the form of the diurnal rainfall data every half-hourly, which was downloaded for 20 years from 2001 until 2020. Half-hourly rainfall is estimated from the integrated multi-satellite retriever by 4GPM or IMERGE version 6B. And then after processing, the result is a file with the data has been deleted and collected will be processed. Processing is done by merging data file in the extension format .nc4 using Python software in the stage of the value of precipitation every half-hourly will be averaged, then the result obtained an average of 20 years of precipitation data. So as we can see, data were analyzed by averaging the data, and then we can see the analysis calculation. The use is HHMM equals HHMMA plus HHMMB plus HHMMC per n. And then after that, after processing, the result is a file with extension format .txt, which will be processed using ArcGIS application. The extension format is changed to simplify processing in ArcGIS. The value and then the value of the txt file is data content point and will be converted to raster data. After processing, a map of distribution of diurnal rainfall will be obtained, and the additional of SSP to obtain to indicate the distribution proceed in Bali Island and the surrounding. Okay, can we next the result and discussion? And the first is annual rainfall distribution over 20 years. The maps show that the range of rainfall value in Bali, its surroundings, is 0.19 millimeter per hour until 0.34 millimeter per hour, marked in dark blue with the lowest value, and red in red color indicating highest value. The value with the highest intensity on the island of Bali is located in the middle of the mountain range. Because mountain range, the highest value is 0.28 millimeter per hour. And then the value with the highest, according to Kayan, the peak of rain in the mountain can be caused by value wind that come and the convergence of sea breezes during the day. The value of rainfall fall in lowland areas when moving away from mountain area. And then we can see the result and discussion. The next is the diurnal cycle distribution rainfall from 000 until 330. The results show that the rain is moving toward the east and began to spread in the northern waters and southern waters of Bali. Meanwhile, the movement of rain in Bali Strait and Lombok Strait is not as wet as the other waters. As we can see, rain's value on this pattern is 0.13 millimeter per hour until 0.20 millimeter per hour. Okay, can we next? And in diurnal rain cycle distribution rainfall from 4 until 7:30. In this period, rain only appears in the north and south with a small value of 0.09 millimeter per hour to 0.16 millimeter per hour. Rain is still dominant in the seas, but slowly away from the mainland towards the north and south. The movement of rain from land to sea can be seen at 4 LT to 730 LT on the Java Island, which directly affect the distribution of rainfall in Bali. Next, the diurnal cycle distribution rainfall at 8 until 11:30. At 11:30 LT, as you can see in the presentation, shows a new peak of rain intensity that occurred in the central area of the island of Bali, which has a mountainous topography. The value of rainfall intensity in the area reaches 0.17 millimeter per hour to 0.24 millimeter per hour. Okay, next is result that show 12 until 15:30 LT. The distribution at 12 LT to 15:30 shows that the distribution of rainfall starts from the mountainous area and spread throughout the land. The peak of rainfall occurs throughout the island at 14 LT with an intensity of 0.63 millimeter per hour to 0.94 millimeter per hour and began to fade at 14:30 LT. Okay, with the next, and then the diurnal cycle distribution rainfall from 20 to 23:30. At the 1930 LT to 2030 LT, the mainland of Bali Island and the surrounding water dries up and tends to have rainfall intensity values of 0.18 millimeter per hour to 0.28 millimeter per hour. The mainland of Bali dries up again in the north and has a light intensity value of 0.17 millimeter per hour to 0.27 millimeter per hour at night. Ocean has a higher rainfall value in the afternoon. Okay, we can move on to conclusion. In this study, we found that based on how diurnal rainfall distribution on the island of Bali and its surrounding for 20 years, from 2001 until 2020, it showed that the peak of rainfall on the mainland occurred during the day at 12 LT until 17 LT, and then rainfall began at the sea occurs from the midnight to early morning from the 00 LT until 4 LT. Okay, thank you for your attention. Okay.
Okay, thank you. Thank you for the presentation from Abdurrahman Shakur. The topic is about the rainfall, diurnal rainfall. Maybe any question from audience? Only left 1 minute and 30 seconds. Yeah. Abdurrahman study about the diurnal rainfall in Bali. Around 20 years, yeah. 20 years. You learn from 20 years. Okay, maybe any expert here about the climate, about the rainfall season? No? Nobody? Yeah. So maybe in shortly, could you evaluate the rainfall this condition right now this year? Maybe if you compare between last year, maybe, because I'm not expert, but right now I think different the pattern of rainfall if we compare the last year. Okay, maybe you can explain to us about this situation right now.
Okay. The okay. Maybe I can speak in Bahasa a little bit. Okay. Yeah.
Okay. The others. Okay.
Okay.
Yeah.
The different patterns rainfall in the 2020 and 2021. Yeah. Okay. The difference is maybe from we can see the phenomena in 2020 is there a La Nina process that makes the difference rainfall distribution. Maybe the result in the 2021 is drier because in 2020 is terjadi La Nina process like that.
Okay.
So yeah, maybe it's impact to the other land like that.
Okay. Okay, thank you. So because of the La Nina, maybe influence the climate here regarding to the diurnal rainfall. Yeah. Okay. Okay. Thank you, Abdul Rahman, for the presentation. And we move to the other presenter. So for the other presenter, you can see the time. The time. How many minutes you still live, you can see in the screen. Yeah. Okay, the committee will show the time left for you. Okay. Okay, the next presenter is Ibrahim Sansari. The title is Paving the Way for More Accurate Earth System Modeling in Malaysia. So the time is yours. Hello, Ibrahim.
Hello, I'm on behalf
Okay.
of Ibrahim.
Okay. Okay.
Mhm.
Okay. Okay. Please. Okay.
Okay, my name is Shahira. So we are from Crops for the Future. So today our research, we are going to present on the paving the way for more accurate system modeling in Malaysia. So on my presentation today, I'm going to cover on next introduction, objective, material and methods, result and discussion, conclusion and acknowledgement. So we are moved to the next. First topic is based on the first topic on introduction. So soil information plays a vital role in the climate change studies. So particularly those that related to soil carbon, storage, microbiome, geomorphological process, ecosystem health, agriculture, land use, and land degradation. So in Malaysia, we have like close to 500 soil series, which were identified and mapped as extensive variety of soil of mountainous, hilly, rolling, underlying level, and semi-terrain landscape. So this association of mapping unit are very helpful in determining general soil type across the country for regional and national planning activities. So however, such data is actually really useful for detailed analysis, such as change in carbon stock and other climate change related studies. So the digital soil mapping technique for mapping of soil properties also has not been implemented in Malaysia. So the major reason for this is that the soil profile are rarely made available publicly, and availability of such data depends solely on conventional survey method for specific purposes, which are often very limited in Malaysia. So a harmonized data of soil property profiles in Malaysia can pave a way for more accurate mapping of important soil properties, such as soil organic carbon and soil carbon stock and carbon pool that is directly related to the climate change studies. So based on this research, we have two types of objective. We have a specific objective and general objective. So on the general objective, we have to develop a framework that assists in Earth system modeling in Malaysia. And we have two specific objectives if we try to develop a framework to compare conventional soil mapping with digital soil mapping. And then based on these two data, we try to correlate the accuracy between both conventional and digital soil mapping. So on this study, we have selected next we move to the material and methods. So in this research, we are select Kedah, which is located in northern parts of Peninsula Malaysia as our study area. So this area cover around 10,430 kilometers square, which this area has a tropical climate with generally flat terrain. And you can see that on the right hand side, we can see the land use of the Kedah, and we can see that the major crop in this area is actually paddy. And we can also see the other land use as well, in which include the rubber and oil palm. It's also been observed in this land use. So next, all right. So based on this study, we are using two types of data set, which is from the conventional soil data. We are getting from the Department of Agriculture. And then we are also obtain the soil physical and chemical soil properties from the department as well. And we have another data set, which is soil digital soil data, which is we acquire from the soil grids, website. The data is actually publicly available in 250 meter resolution. So we are using these two types of data for this research. And later, what we have done using these two data, for the conventional soil data, we do some sort of harmonization, because we know that this soil data is actually have a different soil profile. So if you can see based on this figure 2, these are the example of the soil profile, which every we can say that which every country, they have some sort of their own soil profile. So these are the horizon that we have. So this horizon is actually, we need to convert to the standard depth in order to compare between both conventional and digital soil mapping, in order to know in terms of accuracy, which can we like, is it reliable or not reliable? Okay, so we are using Spline tool in terms of harmonization process. And then next, okay, for the data analysis, okay, as I told before, we are harmonized the data, and then we are based on the Kedah state itself. They have 16 selected soil series, which is represent as a mapping unit. So we harmonize, and we are taking the data from 0 to 30 cm depth, and we are comparing to the soil grid data. So, okay, next. All right. So this is how the harmonization took place, which is we are using the smoothing spline soil depth function. So if you have noticed on the figure 3, actually there are three represent information on the figure itself. We have the actual data, and then we have the spline curve, and then we have the standardized depth data. So once we input the actual depth from the soil data, from the conventional data, and then it will give us the value for the standardized data. So based on this study, okay, next. So based on this study, comparison between the conventional and digital soil mapping. So based on the study, we can see that based on observed soil chemical properties is actually within the range of the soil grid data. So we can say that it allows selected chemical properties to be used when observed data are limited or not available. So however, in contrast, in terms of chemical properties, most of the data point observed, soil physical properties such as salt, silt, and clay were beyond the global soil data, which hinder their applicability in gap filling or observed data. So this uncertainty be associated with measurement error during the original soil survey and prediction error during the data integration. So having, and other than that, having both data set in the different period also could give the dissimilarity in both value in both soil chemical and physical properties. Another possibilities is could be the change of the land itself due to the urbanization and etc. So this is other analysis that we have done to see whether the both data set is correlated or the vice versa. So based on this figure, we can see that the chemical properties seems that close to the digital soil mapping. However, in terms of physical properties, it's likely that a bit beyond the limit. So based on this study, we have come up into the conclusion. Next. So we have come up with a conclusion where with both conventional soil mapping and digital soil mapping actually has the capability in providing the source of soil information. And the conventional soil mapping is actually generating very detailed soil information in the regional scale. However, digital soil mapping are applicable generating in the large scale. So we think that the study should be extended and more work is needed in larger geographical scale, including the data sets and other covariates that necessary to strengthen the accuracy for both soil data in Earth system and related to climate change. So, so I would like to thank next. So we would like to thank and acknowledge our European Unit Horizon Research and Innovative Program, which has been sponsored for this research to us. All right, so with that, I end our presentation and I open for any questions. Thank you.
Thank you, Ms. Shaira, for the presentation. Maybe any question from audience? Hello, maybe because right now is last time, afternoon, close to the night, so yeah, but it's okay. So Ms. Shaira is to compare the conventional data, soil data, compared with the digital data, right?
Yes, yes.
Yeah. Soil grids, is it private or the private?
No, it's actually publicly available. So you can just go to www.soilgrid and we can archive the data from there.
Oh, yes, also public for government
yes.
also. Oh, okay.
No, the government we need to purchase.
Oh.
Yes,
we need to purchase. Okay.
Yes, for this one we need to purchase.
Okay, but this is also institution from the government. This soil grid.
Soil grid is not coming from government. It's from the soil. If I'm not mistaken, I have put the link in the presentation. I can okay, I share you the link afterwards.
Okay.
Yeah. Yes.
So maybe like a state-owned company. The Soil Grid is like a state-owned company. I mean the public company, government company, like that.
Is it organization, a soil organization?
Okay.
Yeah. Yes. Yeah.
Okay.
Mm-hmm.
Okay, thank you, Ms. Saira, for the presentation,
All right.
for the explanation. Okay,
Okay,
thank
thank
you.
you.
Okay, okay,
All
we are
right.
going. Okay, we are going to the next presenter. Next presenter, Veda Sapenti. Hello, Veda Sapenti, are you here? Yeah, I think you are here, Veda. Time is yours. You want to share your PPT, your own or the committee? Hello. Hello. It is a Bengu. I want to share the topic about modeling CAFI, distribution responses to current and future climate change in Southwest Ethiopia. Okay, from Ethiopia. Could you check your voice? Hello? Maybe it's still mute. I cannot hear the voice. Hello, the other person? You can hear the voice? I cannot hear the voice. Mas Freddy? You can hear?
Cek.
Mas Fendi, dengar suaranya?
Dengar, Pak, dengar.
Veda Sapenti. Nggak dengar. Ms. Shaira, you hear the voice of Veda Sapenti?
Yes.
You hear the voice?
No.
No. Okay, thank you. So, yeah.
You mean the Mr. Veda Sapenti voice, right?
Yeah, yeah.
Yeah, no.
No. Okay, thank you. So, Mr. Vedasa, you maybe prepare your devices. Yeah. You prepare devices first, and then after ready, you can join. You can ask to me to present. Okay. Because I cannot hear your voice. Okay. To save the time. Okay. Maybe Afnur Insha. You can present.
Okay.
Okay. Yeah.
Maybe my PPT start with the committee.
No, the committee, Mas Peggy. Okay.
Okay, thank you, Mr. Madhatar, for the time for me for the presenting my article about optimization. I want to introduce myself. My name is Afnur Imsa. You can call me Imsa. I am the lecturer in the Sriwijaya University in Palembang, Sumatera Selatan, South Sumatra. This afternoon, I want to the presenting about optimization of the utilization of blood meal with the palm oil from absorbent fermented as feedstuff to change of nutrients content. Next, please. We know the use of the byproduct from agriculture waste and livestock waste and alternative feed ingredient has been widely used. The utilization of agriculture and livestock waste byproduct, apart from being an alternative feed ingredient, can also reduce environmental pollution. And the agriculture and livestock waste that can be used the palm oil from as a byproduct of oil palm plantation and cattle blood from the waste of livestock. Next, please. We know the palm oil front, most of them will be burned and correcting the climate change phenomena. The use of oil palm front as absorbent for processing cattle blood has never been studied. But at the end cattle blood, most of the cattle blood are not used efficiently and pollutes the environment. Constraint of the use of blood meal are the difficulty in the drying process. It will be a good medium for microbial growth when humidity is high, while drying using sunlight takes a long time for 3 days. And then we can try to the combine of the palm frond and cattle blood for the palm oil frond for the absorbance as absorbent for the technology for the cattle buds for the meal of our feedstuff. Next, please. The research purpose, this study was to examine the fermentation process with different inoculant and incubation time on blood meal with palm frond oil absorbent on the change of nutrient contents. Next, please. Yes, the next. Experimental detail, the study used the completely randomized design with a factorial pattern. Factor A is the inoculant treatment, Bacillus amylolytic flavation, and the Lactobacillus plantarum. Factor B is the incubation time, 0 hour, 60 hour, and the 120 hour. Each treatment was repeatedly 3 times respectively. Method of surface, the dry matter, organic matter, good protein, good fiber, and good fiber and fat crude. The form of proximate analyze. The next. In the preparation of our experiment, the first inoculant preparation, we use the rice bran, edit the amyloid flavation or Lactobacillus plantarum, and then incubation 24 hours, and then the dried at the 60 degrees Celsius. The preparation of substrate, we use the palm oil frond, chopped and the air dried under the sun for 24 hours. And the absorbent was mixed the fresh blood in the ratio 1:1. The blood and absorbent mixed was dried for 3 until 4 hours. The resulting mixture is then mixed with blood and the ratio of 5 to 4, and incubated according to the treatment. And then we can proximate analysis to the next, please. And the result and analysis, we can see in the graphic. There was an interaction between the kind of inoculant and the incubation time on the change of nutrition contents. For the dry matter content, it shows that incubation time had a significant effect with the using Lactobacillus plantarum, while the incubation time had not significant effect with the using Bacillus amylolytic flavacin. The dry matter content increased 61.69% with the use of Lactobacillus plantarum inoculant at the incubation time 60 hours, and decreased 30.11% compared to the incubation time 60 hours. In the organic matter parameter, incubation time had a significant effect during the incubation time at 60 hours. There was an increasing in organic matter, but at the incubation time 102 hours, the organic matter was decreased with the using Bacillus amylolytic flavacin and Lactobacillus plantarum inoculant. Next, please. In the crude protein parameter, in blood meal with absorbent palm oil from fermented increased significant until 120 hours with the using Bacillus amylolytic flavacin and Lactobacillus flavacin. The use of Lactobacillus plantarum saw it and the increasing in the crude protein content which was higher than Bacillus amylolytic flavacin, especially at incubation 6 hours. For the crude fiber parameter, saw the insignificant the decrease was due to the activity of cellulose and hemicellulose enzyme from the inoculant to the substrate. Next, please. There was not significant effect of incubation time and kind of inoculant on the crude fat. It was because Lactobacillus plantarum and Bacillus amylolytic flavacin didn't have lipase enzyme activity for the degrade the fat content. Next. Conclusion, my research is there are an interaction between the kind of inoculant and incubation time on nutrition chain of blood meal with the absorbance of palm oil from, and then Lactobacillus plantarum inoculant with an incubation time and 120 hours, not days, hour, give the best result in the blood meal with the absorbance palm oil from fermented. The nutrition of blood meal with absorbent of palm oil from fermented with Lactobacillus plantarum incubation time of the 120 hours is diameter 43.20%, organic matter 49.79%, and crude protein 10.24%, and crude fiber 24.78%, and crude fat 60.71%. Thank you.
Okay, thank you so much for Ibu Afnur Imsya from Sriwijaya University share the research about the fermentation process with different inoculant and incubation.
Yes.
So using, if I'm not wrong, using palm fronds and cattle blood. Is right?
Yes. Yes.
Okay. So the result is not significant.
Pardon me?
The result is not significant.
Significant in the dry matter contents and organic matter, but not significant for the fat contents.
Okay. 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 Thank you. Maybe any question for other audience? No question?
Yeah, maybe my headset not direct impact for the phenomena
climate
climate
change.
change.
Okay.
But
but accepted.
application about that.
Okay. Okay, thank you, Bu Afnur. Okay, thank
You're
you for the
welcome.
presentation. Okay, good afternoon. Okay. Okay, we are going to the Mr. Vedasa Penti. You can try to say something. Good afternoon. Is there any trouble for your voice? Hello. Not respond. Okay, because not respond yet. Maybe we continue the other presenter. The next is Ifunanya Rita. Are you here? Ifunanya Rita. Hello. Still not here, Ifunanya Rita? Okay. So the last presenter is Purwo Edi Winarto. Time is yours. Hello. Hello, Purwo Edi. When we open this session, Purwo Edi is available. I remember that you available, but right now. Okay, okay. Mas Firda, can you share the PPT? Or maybe me. I also have the PPT from Vedasa Penti. Okay, I will share the PPT. Okay, but I cannot hear your voice. Mr. Vedasa Penti. I already open your PPT. Hello. Bu Afnur, you can hear the voice?
Yes,
No,
I can
not the
hear the
voice.
Mr. Vedasa.
Okay, thank you. Mr. Vedasa, we cannot hear your voice. I already helped you to open your PPT. Yeah, no sound. I don't know. Maybe your devices. Oh. Okay, Mr. Vedasa have trouble with the devices. It's not sound. The sound not cannot hear here. Maybe you can unplug your headset. You are using headset. If you are using headset, you try to unplug. Oh, I cannot hear, and we cannot hear, but you can hear our voice. Okay. Oh, okay. We still have time, Mas Fedi. You want to change the devices? Please be patient. In our room, there's some presenter not come. This is Ifunanya and Purwa Edi. The only 5 presenter, including Veda Sabenti. Hello, once again, Ifunanya Rita. Okay, not available. How about Purwa Edi Minarno? Purwa Edi Minarno? Also not available. So we still waiting for the devices from Mr. Veda Sabenti, and the last presenter, I think. So be patient. Wait a minute. So after this session, I would like to ask all of you to on camera to have screenshot photo after Mr. Veda Sabenti present. So this room, I think it's really international because the presenter is coming from some country, not only from Indonesia, is coming from Nepal, from Ethiopia. From Veda Sabenti is from Ethiopia, yeah, Ethiopia, and Abdurrahman from Bali, and from Malaysia, Shahira. And how about Mr. Hailu Kisa? Hello, Mr. Hailu Kisa. You're not present? You are from the first session, or? Oh yeah, you are from the first session. Okay. Thank you. Still stay here, Mr. Hailu Kisa. You are from where country, Mr. Hailu Kisa? Hailu Kisa Kuma. Not here, my voice. Maybe just okay.
Like, can I start?
Hello, yeah. Where you come from?
Yes, from Ethiopia.
From?
Let's share my PowerPoints.
Oh, you're not present yet?
Okay.
Oh, really? Okay. You are. I see that from the list that you are in the listed in the session 1.
Yeah.
Oh, so you prefer to move to the session 2?
Yeah.
Okay, okay. You can present right now. Waiting, Mr. Pedasa Penti. Okay, okay.
Okay.
You can present. Okay.
Okay, my presentation title is Local Climate Change Implications, Historical Trends, Multimodal Projections and Implications in Blate Catchment, Southern Ethiopia. So climate change is departure in weather events, and it is human effect on climate structure according to these scholars. So this climate change impacted many things, reformed the hydrologic systems, affecting water resource and agricultural production, and frequent droughts in East Africa, according to these scholars. Due to this climate change, climate models were developed to indicate changes and to set adoption strategies. So different climate models had been developed, like regional climate models. So these regional climate models employed individually and in ensemble mean. So ensemble means better performance than in the individual climate models. When we come to tendencies of climate parameters like temperature and rainfall in Ethiopia, February to May and June to September rainfall decreased by 15 to 20 degrees centigrade in mid-1970s and late 2000s, according to the PUNC, as a study by Teshome and Zhang, decreasing annual rainfall totals and increasing temperatures. And most of the time in the country, regional level climate change performed, and my study is to a small catchment. So in this catchment, there is rain-fed and subsistence agriculture could be affected by climate changes. So local climate change investigation is very important instead of national chorus state analysis. So the major objective is evaluation of climate change indications, and specific objectives are analysis of rainfall and the temperature trends, and projection of future projection of the change and characteristics of heat waves, dry and wet months. So my study area is found in East Africa, Ethiopia, to the North Sudan and Eritrea, to the west, South Sudan, to the south Kenya, to the southeast and the east Somalia. So the data used for my study are time series climate research unit data from SEDA, which is prepared by East Anglia University. So historical data was obtained from National Meteorological Agency of Ethiopia, and regional climate model data was downloaded from Earth System Grid Federation, mainly from Cordex Africa. So the methods used are accumulated anomalies of the past climate was analyzed by Lozowski's equation, and trend analysis by Mant-Kandel. Magnitude of trends was evaluated by Tail-Sen estimata, and future climate change evaluation was performed by regional climate model from Cordex Africa data. So temperature and rainfall were evaluated or projected. From temperature, heat waves are evaluated by R package, normal wet and the dry months by using the rainfall data from the projection by SPI, Standard Precipitation Index method, or R package. Let's come to results. The historical accumulated anomalies and the trends were evaluated based on the climate research unit and observed rainfall data. So this is mainly to obtain changing points and variation in slopes. So these were detected. There are increasing trends and decreasing trends in the years. When you come to maximum and the minimum temperature, Both featured upward and downward slopes. Maximum temperature has higher positive deviation from the mean after 1999 and the minimum temperature after 2002. So this indicated warmest years have all come in the 2000s and 2010s in the catchment. And this shows the featuring of warming in the catchment and featuring of climate change indication the catchment was observed starting from 1999 onwards. Let's come to projection of climate model. The projection of maximum temperature in 3 centuries. This century, 2021 to 2050. The second one to 2051 to 2080, and the 2081 to 2100 under 2 emission scenarios relative to the baseline period 1981 to 2010. So maximum temperature, that is mainly monthly mean, portrays increasing trends over the weather stations, Blate, Boditi, Halaba, Hosana. So under both RCPs, maximum temperature is increasing. At Halaba, maximum temperature featured about 1.2 degrees centigrade under this century. So our Blate catchment in mid-century, 0.3 to 1.9 and 1.0 to 2.6 degrees centigrade under 2 emission scenarios, and at the end century, 0.3 to 2.4 degrees centigrade and 1.7 to 4.2 degrees centigrade under 2 emission scenarios. So in mid-century, the maximum temperature will feature be 2.6, in the end century, 4.2 degrees centigrade. So anyhow, the end century is likely become warmer than those in this and in the centuries. So when you come to minimum temperature, the same is true. Minimum temperature over all weather stations are increasing. So the maximum temperature up to 3.5 in Boditi and the Blate weather stations. The projected temperature shows steady increase and in line with some other studies. When it comes to projection of seasonal rainfall in 3 centuries, featured an increasing and decreasing trends under 2 scenarios. The increasing trend is 122 to 3000.9 millimeter and 52.1 to 1111 millimeter under 2 emission scenarios. So the decreasing is from negative 1.4 to 1671 and 247 to 2444.7 millimeter under 2 emissions.
2 minutes left.
Okay. Future dry months. The future dry months are increasing, and also the future heat waves are increasing. Let's come to the conclusion. In Blate catchment, increasing temperature and decreasing rainfall together with increasing dry months and heat waves, decline water resources and reduction in agricultural production. The challenges are lack of data, available literature on past extreme rainfall such as flood, crop failure, and drought. Recommended in planting draws, if planting draws resistance plants such as inset, which is staple to the catchment, planting trees must be based on management decisions. So if indigenous trees plantation in slopy lands rehabilitated and water and soil conservation works implemented, so we can adopt the future climate change. So this study is very important to raise awareness about impacts of climate change for community and the regional authorities to endorse development policies and sustainable mitigation measures. So we want to acknowledge Jimma and the Walaita Sodo universities and also Center for Environmental Data Analysis and Earth System Grid Federation for provision of CRU data and Cortex data. Thank you very much.
Okay, thank you so much for the you're willing to share your result research and sharing information about the season trend for the Ethiopia right now to us, all of us. Thank you, Mr. Helu.
Okay.
Okay. Okay, how about Mr. Vedasa? Mr. Vedasa also from Ethiopia, right?
Yeah, it is. He is from Ethiopia.
Okay. Okay. How about Mr. Vedasa? Maybe Mr. Helu, you can stop your screen. Stop sharing screen. Stop your screen. Okay, thank you. Mr. Vedasa, you want to try? You unmute your microphone. Hello. You can unmute your microphone, Mr. Vedasa Penti. Yeah, I see your screen, but we cannot hear your voice. Please try to speak something. Hello. How to prepare?
Microphone is aquí, pero.
Okay, we can see your PPT. Mr. Vedasa Penti, I think it's okay if you cannot improve. I mean, you cannot solve your devices. You cannot present here. Our committee is okay. We record you. You already present, so no problem. If you cannot solve your devices. Hello, it's okay. You still want to present? Hello. If you cannot prepare, you can repair your devices to. Hello. Okay. So the presenter is already all of the presenter already present. This two presenter not come, and Mr. Vedasa Penti, we consider that you are already attend and already present. Yeah. Even though you cannot repair your voices, so we consider to you that you already present, so no problem. Okay, Mr. Vedasa Penti.
Thank you very much.
Okay, so you stop your screen. We will close our session. Please stop your screen, Mr. Vedasa Penti. We want to take the screenshot our photo please. Okay, thank you. Thank you, Mas Reddy. Maybe you can take the photo and please, all of presenter open camera to have the photo. Please, Mr. Abdurrahman Shakur and the other presenter, Mr. Fekadu. Okay, already. Okay, Mas, you can take the picture.
I did present it already. In morning session.
Hello.
I did present. I presented it.
Oh, okay, thank you. No problem. Okay.
Yeah, okay, okay.
Okay, thank you. So we just take a picture already, Mas Reddy?
Yes, yeah. I think for my section, I just presented. So thank you for that invitation.
Okay. Mr. Reddy? Sudah selesai, Mas Reddy? Okay. Thank you very much for our session for all of presenter attendants here. Me as a moderator, maybe as apologies if any mistake that I have on this session. And once again, thank you so much for your participation to the 7th International Conference on Climate Change. And we are waiting for your attendance for the next session and the next ICCC, maybe in the next year. Okay, thank you so much. Yeah.
Thank
Good
you.
afternoon. Good afternoon.
Thank
Okay.
you, gracias. Thank you for having
Yeah.
us.
Okay. Success for all of you.
Yeah.
Okay.
Thank you for having us. This
Okay.
meeting was very nice.
Okay.
Thank you very much.
Thank you.
Yeah.
You can leave. Yeah. Mas Freddy nggak perlu base center ya, nggak perlu kan?
Centernya iya Pak, belum ada dari season pertama tadi.
Oh, enggak. Apa ada perintah?
Ada Pak, dari setiap ruangannya ada salah satu gitu.
Sesi pertama belum dipilih.
Belum.
Sesi pertama belum dipilih. Oh. Kalau sesi kedua
tidak ya Pak. Nanti kalau pengumuman presenternya nanti bisa lewat WA saja Pak.
Oke.
Terima kasih Pak.
Saya boleh live ini?
Yes.
Oke, terima kasih.
Langsung end.